Hi, Professor Zema Ekpete. Welcome my viewers and students to this topic called Calculations of Absolute and Relative Error. But before we continue, we'll have a recap of our previous lesson. In our previous lesson, we talked about errors. We said error is the difference between the measured value and the true value. We said there are two types of errors, the determinate or systematic error and the indeterminate or random errors. We said the determinate errors are those errors that we know their sources, while the indeterminate errors we do not know their sources. In today's class, we shall be talking about how to calculate absolute and relative error. And at the end of this class, I expect that my students should be able to understand 1. Calculation of absolute error, 2. Calculation of relative error, 3. Representing of errors as pass per 100, and 4. Representing errors as pass per 1000. What is absolute error? The absolute error is the difference between the measured value from the true value. The measured value is the measurement that the researcher got. The actual values are the values from the analyst, the standard analyst. So let us look at this example 1. Calculate the absolute error where the measured and actual values are 240.15 mm and 213.03 mm respectively. In this question, you are given 240.15 mm as the measurement of the researcher, which is the measured value. And then 213.03 is the standard value. You subtract both, and the absolute error was gotten as 27.12 millimeter. Consider example 2. The result of an analysis are 35.97 grams compared with the accepted value of 37.40 grams. What is the absolute error? The absolute error is 35.97 grams minus 37.40 grams. In this error, you will have a negative value, minus 1.43 grams. It tells us that it is 1.43 grams unit below the true value. Sometimes the formula for absolute error is written as a bar called modulus when dealing with multiple numbers. The modulus symbol is needed as some numbers may be negative. For example, if you are told to find the total error from the following addition, both measurements have absolute error of 1.43 grams. If you are told to find the total error of minus 1.43 grams plus 1.43 grams, we know that both measurements have absolute error of 1.43 grams. If added together, the total error should be 2.86 grams. But because of that negative sign, you will get a 0 gram, because minus 1.43 grams plus 1.43 grams will cancel out and give you a 0 gram. But to avoid that error, we can solve this by taking the absolute value of the results and then adding using the modulus symbols. If we add now modulus minus 1.43 gram plus 1.43 gram in modulus, we are getting a result of 2.86 gram. So the modulus sign is used when we have various values to add together, positive or negative. When the known value is not known or is not given, then the absolute error is equal to the greatest possible error. For example, in the measurement of zinc in fish, the concentration was found to be 8 plus or minus 0.05 milligram per kilogram. In this case, the absolute error is 0.05 milligram per kilogram, which represents the standard deviation from that measurement. What is relative error? The relative error is the ratio of the absolute error of a measurement and the actual value of the quantity is the relative error, and it can be expressed in percentage in parts per 100 and parts per 1,000. Relative error can be calculated when we have absolute error. From the absolute error, you divide it with the amount of the actual constituent. The relative error shows the significance of an error by comparing it to the original measurement. For example, let us consider this example 4. It says calculate the absolute error and percentage relative error of zinc in a fish if the concentration is measured to be 5.00 plus or minus 0.02 milligram per kilogram. How do you calculate the absolute error from this work? From this work, the absolute error is the value of the standard deviation, which is 0.02 milligram per kilogram. So, from the work, we'll have our set of data, the mean, as 5.00. So we will use the absolute error and divide by the mean, and that will give us the percentage relative error. So the percentage relative error is equals to S over S bar times 100. Percentage relative error equals to 0.02 milligram per kilogram over 5.00 milligram per kilogram times 100. The result is 0.5%. Example 5. Calculate the relative error in parts per 100 and parts per 1,000 of chromium in canned meat when the true value is 4.50 milligram per kilogram and the measured value is 4.85 milligram per kilogram. From the above question, we already know the measured value and the true value. So if we subtract 4.85 milligram per kilogram minus 4.50 milligram per kilogram, we'll have 0.35 milligram per kilogram. That is the absolute error. Remember, the absolute error always has unit of measurement. Then the percentage relative error will be 0.35 milligram per kilogram, which is the absolute error, divided by 4.50 milligram per kilogram, which is our actual value, times 100, and we will get 7.7%. This is our relative error in parts per 100. If we want to get our relative error in parts per 1,000, we will multiply by 1,000. The answer will be 0.35 milligram per kilogram divided by 4.50 milligram per kilogram times 1,000, and we will get 77.7 parts per 1,000. What is the difference between absolute and relative error? We have about 4 major differences here. In definition, 1, the absolute error is the difference between the measured value and the actual value of a quantity, while the relative error is the ratio of the absolute error of a measurement and the actual value of the quantity. The determinations. Absolute error determines how large the error is. Relative error determines how good or bad the error is. In size of quantity, absolute error varies depending on the size of the quantity. The relative error does not depend on the size of the quantity. And in unit, absolute error has the unit of measurement, while the relative error is dimensionless. It has no unit. I want you to give me a feedback from this work. I've given an assignment here. A reaction between 1 mole of sodium and 1 mole of chloride should yield 38 grams of sodium chloride. In your experiment, the actual yield is 32.75 grams. So calculate A, the absolute error, B, the percentage relative error, C, the percentage relative error in parts per 1,000. Write the answer in the comment section. Thank you. For our next class, we'll be considering sampling. Don't forget to subscribe, like, comment, and share this video. See you in the next class.